Hi everyone, so welcome back to my channel and let's start with today's Leetcode question, that is remove some folders from the file system. So till now we have completed 13 questions. In case you have missed any, you can watch it on my YouTube channel. I've created a playlist for the same, and in case you have any comments or suggestions, please do share in the comment section. I will review them and work upon them. So let's just quickly read the problem statement. So we are given a list of folders. Return the folders after removing all the subfolders in those folders, and it is like somewhere confusing. So let's just go over the next one. If a folder I is located within another folder J, it is called a subfolder. Okay, and a subfolder folder J, it must start with the J followed by a slash. For example, slash A slash B is a subfolder of A. Okay, because if this is a parent, this can be a sub folder, right? Okay, got it. But slash B is not a subfolder of slash A slash B slash C. So we are getting that the subfolder should start with this parent folder, and after that there's a slash, and you can do like any subfolder can come, right? And if you directly see the example, it is like slash A slash B, and then CD, similarly CDE and CF. So how many are parent folders? If you directly see, A is already parent folder, and this is a subfolder because A is already coming with the slash, and CD, yes, it is a parent folder. Now this is parent, no, because CD is already coming with a slash, so it is not added. CF, yes, it is a parent because there is no subfolder for it. There is no parent for this one, so it is a parent only. So directly you can see there are three sub parent folders. So we'll just move to the intuition building part, and then we'll do the coding. So I don't think that is this question is like compared to medium, it can be solved easily if you just get the intuition. So we'll do that. Okay, so let's just start with the example. Let's just say this is our folder and we have an array of multiple folders. So this is A, this is B, this is just say C, this is C, D. Okay, now we have to remove all the this subfolders. So we can see that this is coming in this folder, so we will remove this. Similarly, this is coming in this folder, so we will remove this. So at the end, what we have, our answer would be slash A slash C. So how we can build our answer basically? So this array, first part, this array can be in any order. So it can be like in this form. It can come here and this can come here. So it can come here. If you now see that we cannot go directly to this A. Okay, and let's just say we have first this folder, we will store it somewhere. After that we'll come here and check if it is coming in it or not. So first approach, so let's just discuss the first approach. Okay, and we have this array in a non-sorted order. So first, what will you do? You will come to here A. Okay, you see that it is not currently being seen, so you just add it somewhere in your some storage or anywhere, right? Now you come to here. Now what you will do, you will check if this is coming in the any folder of your storage. This is not coming because this is different from this A, so you will add it slash C slash D. Okay, now what you will go, you will go to here, the C. What you will do, you will check if any of this C came into any of the folder. If you see that it is not here but it is present in this, and this is come somewhere smaller than this, because this length is already smaller, but until this point it is equal. So what you can do, you can basically remove this, saying this is a subfolder, and add your C, because this is your parent currently. Okay, now you will go to this AB. What you will do, you will come to this A and check, and this C and check. So this will be your storage, and you will check for all the folders. So AB, you will check yes, because this can be found in this. Okay, the common string in both of them is only till this one. So you can remove this, right? So now your answer will be the storage, right? Storage will be slash a and slash c. So this is how you can find your answer in a brute force way. So this is your brute force, right? You go to every your folder and have your storage and go to each folder in your storage, and if you do not encounter any folder that is somewhere like this is present in any of the folder, then you will add this folder in your storage. So let's just say this is called folder storage. Okay, parent folder storage, good meaning. So and after that you will return your parent storage saying that this is only the parent folders that consist of all of them. So now you see you are going very brute force approach, and in this how much time that you will need. So time complexity and space complexity, you see that you are using some space, and in the worst case it will be big of n. Okay, because if all the folders that are like you are doing, so all of them can be added saying that all of them are parent. Now time complexity, because for each of them you are going in this parent array every time, right? And in the last case, let's just say you are at the c and you are going for a and c both. So how much time you are requiring? So you are somewhere requiring O of n square, okay? Because this, let's just say this size is n, okay? And all of them are parent. So you will add every time to the parent, and for every folder you will check in the parent. So it is kind of somewhere big of n square. Okay, so we see that this is big of n square. Now what we will do, we have to improvise on this, okay? And we see that first this is non-sorted. Okay, if we try to sort it lexicographically, lexicographically means that every in that lexicographically sorting, that each character will be compared, okay? And the one that is of lower precedence, let's just say because a comes before c, so it will be given first priority to come first in a sorting. So now when this will be sorted, slash a slash c slash d slash a slash b and slash c. Okay, so in this the lexicographically sorting will make it like first slash a will come, then slash a slash b, okay? Because if you see after lexicographical sorting, a is of lower precedence, so it will come first. This c will come because this part of c is already here, but this is greater, okay? So after that c slash d, right? Now you, what you can do, you know that in your answer will first should also be there, always be there, okay? Minimum one should always be there. There's no answer that you will remove all of the subfolders. Minimum one should all be there. So first you will add this in your storage. Let's just say you have this a. Now you will go for all the like subfolders from second index, that is one index, to until you reach any parent folder, right? So now you see this is, you will compare it with this. So slash a slash b, yes it is coming, so you will not add it. You come to c, now you check c with this a, no it is not present, so you will add c. Now you know all the folders that are coming after c will be like greater than this or will be subfolder of this. They will not be subfolder of a, okay? They will be subfolder of c. Now you just have to compare this cd with the top of this, because you already have the top, the parent on the top. You just have to compare it with this, not to the a again that we were doing earlier. So now you will just compare it with this one, and now it is like subfolder, so you will not add it. So you just have your answer, and this is your same as the previous one, right? So we have got our answer, and what we are doing? We are just doing sorting. And this is, what is this? We can take any, like, we can take any data structure. In this, I will be using vector of string. Okay, so now we will do the time complexity part. So time complexity, directly we see sorting, and the number this we have taken above is n. So the sorting will be n log n directly, right? And then the comparison is not that much greater. Okay, so we see that this is n log n, and then we are saying that will be like directly n. But the one thing that we have to take into account, that this n log n is a sorting part, but when in the sorting that we are comparing these two strings, their length might be like very large, and that comparison time, that I see that most of the people take it around big of m. So the time complexity is m cross n log n. Okay, this is a comparing time of two folders, because their folder length can be like 100. Okay, so this 100 will be compared with this 100 or anything. So that we are considering big of m time, and m is the, like, m, where m is the size of each folder, okay, or length of each folder. So we directly see time complexity is this, and space complexities are the answer that we are having, and max it can have O of n. So we are taking this into account, the answer that we are returning. Else we can directly say, if we are not accounting this, so it will be big of 1 only, right? Okay, so now we will go to the coding part to make it understand more, and I will give you a one solution more at the while we are writing the code, to make it more understandable. So let's just move to the coding part. Okay, so let's just quickly start the solution part. So first we have to sort this folder. So sort folder dot begin and folder dot end. Right now we have sorted. First we have to create our answer. So vector of string our answer. Right now we have to add our first parent folder. So answer dot pushback our folder 0. Right now we have first parent, we will go for other parents if we find. So for from 1 till folder dot size, right, and pi plus plus. So first we will get our current folder, so that will be folder of I, and your last parent folder, so that will be your last in the this answer array, so it will be answer dot back. Now you have both of them. What, how you can compare? If you see that we have discussed that this will be compared with this b, but instead if we is like this, so how you can compare? If you like have this and you can compare this size, same size you can get. So this will be a size 4, a 3, and this will be a size 3, and it is not equal to this. So that means this is different parent, you can add it. But if it is like this, then you can directly check that 3 size is equal to this size, and yes, this is your subfolder. So now last parent folder will be added 1 slash, so that you can get this, right? Now what you will do, you will compare your current folder dot compare. We already have one compare function in C++ to directly compare with the index position. So 0 till last parent folder dot size, because we have to take the size of the parent. So now under last parent folder, right? So it will compare. If it is not equals to 0, that means that they are both different, and if they are both different, that means that the coming one is also a parent. So we will add our answer dot pushback our current folder, because that means the current folder is also a parent of upcoming. So after that we will return our answer, right? Now we will just try to run it. So Yes. Yes. Yes, it is running perfectly fine. So we'll try to submit it. Yes, so it is submitted successfully. In case, so thanks everyone for watching. In case you do like this video, please do hit that subscribe button and turn on the notifications. And one thing that we have to discuss about the next method that I've asked. So second optimal method, first you should try on your own how you can optimize this, and if you not, then you can watch this video continuously. So what you can do, because the sorting is n log n, and that comparison in the sorting will be a big of m that we have discussed. But now what you can directly do, you can create one hash set. Okay, create a hash set and add all these folders in your set. After that, you again come to this folder, and for each folder you can compare with the values in the hash set, and that comparison will be big of 1 directly, because this comparison, if you see, is also a big of n, a big of 1, right? But the most important time consuming is this sorting, and this will be like optimized when you use hash set, and it will be somewhere big of n star m, right? You can try this implementation on your own. In case you find any difficulties, you can ask in the comment section. I will try to provide that code, and I will also create a video if you suggest. So thanks everyone for watching, and in case you like this video, please do hit the subscribe button and turn on the notifications. Thanks everyone.